Hi there. In this video, we're going to be looking at implicit functions. So firstly, we want to answer the question, what is an implicit function? An implicit function is a function in which we cannot clearly see that on the left-hand side, we have all the variables, and the right-hand side, we have all the other variables. So generally, we can have y is equal to x squared. Okay, so y is a function of x. Y is on one side and x is on the other side. So an implicit function is different in the sense that we cannot clearly make one variable in terms of the other. So an example with this would be perhaps x squared minus xy minus y squared is equal to 0. Okay, we can see that to put all the y's on one side and all the x's on the other side, it's not going to be a very easy thing. So is it possible just by looking at this equation to find dy dx? That is, we could do it like try to find y in terms of x, express y in terms of x only, and then find dy dx. But is it possible just to find dy dx using just the function as it's written? Well, there is a way to do that, and it's to use our magic formula that we have derived thus far in the previous videos, and that is delta z is equal to dz dx times delta x plus dz dy times delta y. So you might be wondering, where on earth does the z come in now? What is the z? Why is the z here? Okay, so what we do is that we would let this entire equation equal to z. This implicit function, we would just let it equal to z, and it's equal to 0. So z is actually equal to 0, and it's equal to this implicit function. So the first thing that we can do is we can divide this equation by delta x. So if we do that, we get delta z divided by delta x equal to dz dx. Delta x over delta x is just 1, so we'll just not write it, plus delta z or dz dy multiplied by delta y over delta x. So if we now let delta x approach 0, what this means is that delta z over delta x will now approach dz dx, and delta y over delta x will approach dy dx. So if I write this formula now in terms of the derivatives, I get dz dx is equal to dz dx plus dz dy times dy dx. And what are we solving for? What do we want? Well, going back to the problem as we have stated it, we have an implicit function, and we want to find dy dx. So are we in a position to do this now? We have an equation that does contain dy dx. And here it is. So we just express this in terms of dy dx. So dy dx is equal to dz dx minus dz dx divided by dz dy. However, if we look at the original problem, we can see that we have called z to be this entire function. And what is z equal to? Z is equal to 0. Z is equal to 0. So what that means is that dz dx must equal to 0 as well. This equation that we have now derived simplifies. So dy dx is now equal to minus dz dx divided by dz dy. So back to our original problem, we had x squared minus xy minus y squared equal to 0. And all we need to do to find dy dx is to just use this formula. So the first step is to let z equal to this function. So we'll state that z is equal to x squared minus xy minus y squared. And we firstly compute dz dx. So dz dx is equal to 2x minus y. Of course, we treat y as a constant, and then we do the same with y. Dz dy is equal to minus y minus 2y. My apologies. This should be minus x. Minus x minus 2y. So the derivative of x squared is just 0. The derivative of minus xy with respect to y is just minus x, because the derivative of y is just 1. So it's minus x. That's how we got that. And minus y squared is just minus 2y. So applying this formula as we have it, dy dx is just 2x minus y put a minus in front of it, divided by minus x minus 2y. That's our answer. Well, of course, we could take minus 1 as a common factor, bring it out. So if we really wanted to do that, this would become 2x minus y divided by x plus 2y. So this is how we use our differential function. We take a function differential, and we're able to compute the derivative of that implicit function using our function differential. So this is an important application of that.